This is just a quick video about finding LCM. So LCM means least or lowest common multiple. Common means in common between the numbers we're talking about, and multiple means multiples of that number. So we do it sometimes if we're looking to find patterns when things loop around at the same time together. If something is going around and around and around, and another thing is going around and around and around, is there a time when they meet up? If you're finding common denominators for fractions, you want to add or subtract fractions, you'll need to find LCM. And sometimes you just need to find it to clean up a mess before you get started on a really big problem. So the two main methods are the first one, to list the multiples. So if we want to find the LCM of 12 and 9, 12, we would write out all the multiples. 1 times 12 is 12. 2 times 12 is 24, 3 times 12 is 36, 4 times 12 is 48. We would write out a few and hope that the answer comes up soon. Then for 9, we would say, okay, 1 times 9 is 9, 2 times 9 is 18, 3 times 9 is 27, 4 times 9 is 36, 5 times 9 is 45. And we look at these lists and we say we want a number that shows up in both. Has to be in both lists, and we want the smallest one. So there's only one number that shows up in both of these lists, and that's this 36. So the LCM of 12 and 9 is 36. We'll show another way that I like a little bit better. Using this ladder method, we divide as many times as we need to, and we try to divide by both. So we've gone over this one in class before. So 12 and 9, I can divide them both by 3, so I will. 12 by 3 is 4, 9 by 3 is 3. And if you can't divide both of them, if I was looking for the GCF for these two, I'd be done, it's 3. But for LCM, I'm going to keep going until there's all ones on the bottom. So I'm going to divide by 3 again, just to get it out of the way. 3 by 3 is 1. 4 by 3 does not work, so we just bring that down. That's just 4. And now I can divide by 2 to get 2, and 2 again. And now I have 1s on the bottom, I'm all done. I've chosen to do all prime numbers on the side here. Oops. I've chosen to do all prime numbers on the side because these ones are all primes. That just makes sure that I have the very lowest number possible. Now if I take 3 times 3, which is 9, times 2, which is 18, times 2, I get 36. So I could say LCM is 2 times 2 times 3 times 3, or another way to write that using exponential notation would be 2 squared times 3 squared, which is still just 36. So it's the same answer as we got up here, but I like it because no matter how many numbers we have in a list, it's kind of one thing to write out. If we're finding the LCM of 5 numbers, writing out 5 sets of multiples can get very tedious. So here's a problem using LCM. It says there's 3 flashing lights. One flashes every 3 seconds, another every 4 seconds, and the last one every 5 seconds. How often do they flash together? So if we find their LCM, we want to divide them by whatever we can to get 1s on the bottom. 3, 4, and 5 aren't nice to play with here because there's not anything they have in common, but we'll do it anyways. We'll divide by 2. We'll divide by 2 again. Remember, if something doesn't work, just write it on down. Divide by 3, and what's left is just that 5. And we get 2 times 2 times 3 times 5. And 2 times 2 times 3 times 5 should be 60. 2 squared times 3 times 5, which is 60. So every 60 seconds, once a minute, they will flash together. Here, this one, I've just included this extra bit of the problem to show why the ladder method is really fast. So if we have another one that flashes every 2 seconds, the same problem as before, lights that are flashing. And now we have 2 more lights, another one that flashes every 2 seconds and another one every 6 seconds. So now we have every 2, 3, 4, 5, and 6 seconds. I'll just start doing my ladder method. Divide by 2. I've got another 2 I can do. I like to work from smallest prime number up, just so that I don't miss any. Divide by 3. Oops, that's a 1. And divide by 5. Now I have all 1s on the bottom. That means I'm done. And my LCM is 2 times 2 times 3 times 5, which is the exact same answer as it was in the last problem. 60. So adding those 2 more lights could have been a lot more work, but here we can quickly show, just in one little grid of numbers, that these lights will still flash together every 60 seconds. Your alternative there would have been, here's my 2 times tables, here's my 3 times tables, my 4, 5, and 6, and I would have written out, okay, 1 times 2 is 2, and then 4, and then 6, and then 8, and then 10, and then 12, and I would keep going. And for the 3s, I would say, okay, 3, 6, 9, 12. I would keep going. For the 4s, okay, I go 4, 8, 12, 16. Looks really like 12 should be our LCM until I get to 5. So I can do 5, 10, 15, 20, 25, and so on. And for the 6s, I would write out 6, 12, 18, 24, 30. And I would have to write until all of these numbers got down to, here's a 60 over here, here's a 60 over here, here's a 60. That would be just fine if I have a lot of time. So instead, this ladder method can save us a lot of time.